Hello and welcome to another late night coding session with Rune. Today we're going to talk about boxing in Rust and specifically what it does and when you should use it. First thing you have to know is what the stack and the heap is. It's very easy. When you compile a program, it gets loaded into a region of memory called the process memory, and this is essentially where it executes and where it can store stuff, right? So when you're say let's do this, when you make a variable, it gets put on the stack, and so the stack and the heap are two sides of this memory essentially. So the heap grows from left to right and the stack grows from right to left, for your definition of right and left. Essentially, when you enter functions and all the variables in functions, and when you pass arguments from one function to another, those are all stack variables. So these all live in this side of the memory. And the stack is really meant for stuff that the CPU can access really frequently, really quickly. And it essentially enables all the function infrastructure, right? Calling functions, returning from functions. The heap, on the other hand, is really meant for large objects that you access by yourself. So usually when you create a pointer, it points to something in the heap because you control that. You don't control the stack very much, right? The CPU controls the stack. You control the heap. And so boxing is essentially saying like, hey, I know I just created this value and it lives on the stack, but let's place it in the heap, okay? So that's basically what you do. So let's look at this. So here we have a simple program. We create the stack variable a and we print it. That's fine. This was another attempt. And then we can say, I mean, there's no difference, but we can create a boxed 10. And this essentially tells Rust, like, hey, I have this value, put it on a heap. Nothing's going to change. The only thing that changed is where a lives now. So if you would actually look in the memory of the program, you'd see that this 10 now appears here instead of there, depending on how you compile. We'll get to that later. I can show you an example of when you can store something on the stack. So obviously the stack is very CPU based. CPU has to do a lot of things, a lot of context switching, it has to clean up stuff. You can't really store too big objects there, right? They're meant to go on a heap. So for example, if we create a big array, let's create an array filled with zeros, like this, then printing it will not work because we have a stack overflow. This means it tries to make a billion zeros here on the stack, and it grows and it grows and it grows, and eventually you just run out. Just run out of space, and it doesn't work. And even in release mode, doesn't work. Core dumped. So what you do is you put it on the heap. If you really want it, you put it on heap, right? And so if we run it in release mode, it gets put on the heap, and then it tries to print a million zeros, right? So yeah, I mean, that's essentially it. Why did I do a release? Because in normal debug mode, it doesn't really optimize anything. So it sees this here. It says like, okay, I'm just gonna blindly create it, and then I'll see what function comes next, which is the box new, right? But you want this all to happen at the same spot. You want Rust to know to allocate this on the heap. And so this together in release mode actually compiles properly. I think that's really all you need to know. So just be aware. If you have structs or anything complex, put it on the heap. If you have anything that's small or easy to copy, just keep it on the stack. You don't need to use a box. And something you should also know is that box has a counterpart called arc, or RC, I guess. But as you can read here, this is also allocated in the heap. but arg is very cheap to clone. Arg is essentially a non-unique reference, so you can't do anything mutable on it because you have multiple readers. But you can cheaply copy it. A box is owned. So this is essentially a mutable reference to a heap object. I hope that helps a little. And yeah, just this is what it is. This is boxing in Rust. I'll see you next video. Bye bye.